Let's talk about dilution. First, let's define two concepts. A stock solution is a solution in concentrated form that is then diluted. And dilution is defined as enough solvent is added to a stock solution to increase volume of solution while keeping the solvent amount constant. As an example, in this figure we have a stock solution. So it has a certain amount of solute with n number of moles, and let's call it just general n. And it has an initial volume of solution. Let's call it V initial. So we can define a concentration initial as the number of moles, n, divided by the volume of the solution. We can then multiply the volume on both sides and get the following equation. The number of moles is equal to the concentration times the volume. If we then increase the amount of solvent, so we add water, so this will increase the amount of solution, so the volume will increase. And at the same time, if n is constant, because we're not increasing the amount of solute, then the concentration will have to decrease. So if we define a concentration final with the same number of moles and a volume that is increased, then the concentration will have to be decreased. So we can define the following equation. With the same number of moles, this is equal to the concentration final times the volume final. So the two concentrations are the same. We can define the following equation. Initial solvent in moles is equal to the final solvent in moles. And this is equal to concentration times volume initial and equal to concentration to volume final. And this is the dilution equation. Remember that we have to do a unit analysis where the concentration is in moles per liter and the volume is in liter. So this is on both sides. You have to have the same units for each factor. Now, if you have volume in milliliters, make sure that you convert it to liters, or that your other side of the volume is also in milliliters, so that they can cancel each other out. Or you can convert both in liters. Let's go over one example. So here it says that you need to prepare 250 milliliters of 1.25 times 10 to the negative 3 molar sodium hydroxide aqueous solution. And we'll use a 0.0380 molar sodium hydroxide stock solution. How much stock solution do you need? Okay, so first we know that the initial concentration of the stock solution is 0.0380 molar. We need to know how much of this initial volume we need. The final concentration of the diluted solution is 1.25 times 10 to the negative 3 molar, and we need a final volume of 250 milliliters. So we can use the equation for dilution where the unknown is the initial volume. So let's set this up. So we have 0.0380 molar times initial volume, which is the unknown. And on the right hand side we have 1.25 times 10 to the negative 3 molar times 250 milliliters. Remember that I'm keeping the units of volume in milliliters because I'm expecting my final answer of the initial volume to be also in milliliters. So let's see how that happens. If I divide both sides by the initial concentration, then we see that on the left hand side it cancels. So we have that the initial volume is equal to 1.25 times 10 to the negative 3 molar times the final volume and divided by the initial concentration. So the units of molar cancels out and we're left with units of milliliters. So our final answer will be milliliters. Now we have to multiply 1.25 times 10 to the negative 3 times 250 and divide it by 0.038. So our final answer must have 3 significant figures because all of these factors have 3 significant figures. So we get 8.22 milliliters. And that's our initial volume of stock solution that we need to get this concentration and this volume. Let's do one more example. This example says, to prepare a fertilizer solution, a florist dilutes 1 liter of 0.20 molar ammonium nitrate aqueous solution by adding 3 liters of water. So this first sentence has the following information. The initial concentration of the stock solution is 0.20 molar of ammonium nitrate. The initial volume is 1 liter. The final volume of the diluted solution is 1.0 liters plus 3.0 liters, so 4 liters. And the final concentration of the diluted solution is unknown. The problem continues. The florist then adds 100 milliliters of diluted solution to each plant. How many moles of nitrogen atoms will each plant receive? Solve this exercise without using a calculator. Okay, so after finding the final concentration of the diluted solution, we need to find in 100 milliliters how many moles we have of ammonium nitrate. And from there, in the same 100 milliliters, how many moles of nitrogen we have. And that's what the question is asking. Okay, so let's go step by step. First, we need to find the final concentration. So we use our dilution equation and the unknown is the final concentration. So we need to solve this equation for the final concentration. So that would be equal to initial concentration times initial volume divided by final volume. We have all of these numbers. So this would be 0.20 molar times 1 liter divided by 4 liters. Notice that each of these numbers has 2 significant figures. So the final answer must have 2 significant figures as well. This gives 0.050 molar. So molar can also be in units of moles of ammonium nitrate per liter. Okay, so from there we need to find how many moles of ammonium nitrate we have in 100 milliliters of this diluted solution. So we use the following equation. For this concentration, we can have a certain number of moles divided by a volume. So we need to find the number of moles in a volume of 100 milliliters. And 100 milliliters is equal to 0.100 liters, keeping the 3 significant figures. So rearranging this equation and solving for number of moles, this would be the final concentration times the desired volume. So this is 0.050 moles of ammonium nitrate per liter times the 100 milliliters, which is 0.100 liters. So units of liters cancel out and we have number of moles of ammonium nitrate. So this answer must have two significant figures because that is the least number of significant figures in one factor. Here we have two. Okay, so that should give us 0.0050 moles of ammonium nitrate. And then we need to convert this number of moles into moles of nitrogen. Okay, so from the formula of ammonium nitrate, we have 1 and 2 nitrogen for every molecular formula of ammonium nitrate. So for 1 mole of ammonium nitrate, we have 2 moles of nitrogen. Okay, so that's the conversion factor that we will use. So we have this number of moles of ammonium nitrate and we use our conversion factor. 1 mole of ammonium nitrate for every 2 moles of nitrogen. So moles of ammonium nitrate cancels. So we multiply 2 times this number of moles. And the final answer gives us 0.010 moles of nitrogen. And it has two significant figures, and that's our final answer.